Hi everyone, welcome to this brief announcement on ParlayLib, a toolkit for parallel algorithms on shared memory multicore machines. I'm Dan, and this is joint work with Blelloch and Laxman Dhulipala. So there are many existing tools for parallel programming, many of them written for low-level languages like C and C++. There's Silk and Silk Plus, originally developed by MIT, which is a C++ language extension that adds nested fork-join parallelism to the language. There's OpenMP, which is a framework for parallel programming that's integrated into a wide range of languages. There's Intel's Thread Building Blocks, which is a C++ library for parallel programming. It has a scheduler, it has a memory allocator, and several useful data structures. And recently, there's also been a standards proposal from the C++ community that tries to integrate parallel versions of many of the common C++ standard library algorithms into the library standard. So while these tools all provide useful things for parallel programming, they don't necessarily have the kind of high-performance, wide range of parallel primitives that you need to implement really high-performance parallel algorithms. So to fill in that gap, we built ParlayLib. ParlayLib has several goals, which I'll briefly cover here. It's supposed to be easy to use. It's a very tiny header-only library with no dependencies. You can just include it and you don't have to link anything. It's very easy to use. It's fast and scalable. It's been used in a wide range of research projects, both in industry and in academic research, and it's been shown to scale beyond 100 threads. It provides support for many advanced parallel primitives, so in addition to the standard things you would expect from a standard library. It also provides non-standard things like integer sorting, semi-sorting, computing histograms. We have a range of data structures from things like parallel sequences, which are essentially a parallel version of a C++ standard vector, but they support updating, modifying, initializing, and destruction all in parallel. And we also have a concurrent hash table, and we also have a delayed sequence, which is basically a lazy functional sequence that you can use, which is very useful for speeding up parallel code. In addition, all of the implementations in ParlayLib are theoretically efficient algorithms. So if you write your own programs composed of the primitives in ParlayLib, you can guarantee that your program will have good theoretically efficient bounds by using the bounds on our primitives. And lastly, if you're already using Silk, OpenMP, or TBB, and you don't want to switch entirely, that's fine. Parlay integrates neatly with those systems just fine. It will happily use those systems' parallel schedulers in place of its own if you just want access to Parlay's algorithms. It's completely compatible. So let's briefly go over some of the features. We have several data structures. Like I mentioned, we have a parallel sequence, which is like a parallel version of standard vector. It does initialization, modifications, and destruction all in parallel, as well as some other neat features like being able to initialize it from a function, from a generator function. We also have a delayed sequence, which is essentially a lazy functional sequence that generates its elements on demand. This turns out to be really useful in parallel programming because it can save you a lot of memory in situations where you're dealing with sort of compositions of sequences and you don't actually want to make copies of everything. This actually in practice can speed up some algorithms by a factor of 30 by using this because it can save a lot of memory. And we also have a phase concurrent hash table. So it's a hash table that can do constant time insertion, deletion, and lookup, provided that you do all your insertions concurrently, or deletions concurrently, and lookups concurrently, but don't mix them. We also have parallel scheduler and memory allocator. So the scheduler, again, it's lightweight, header only, very easy to use. It supports nested fork-join parallelism and parallel for loops, everything you'd want from your favorite parallel support library. And its performance is competitive with existing libraries like the ones we mentioned before. And we also have a pool-based memory allocator, which has been shown to scale really well. It works on programs that use up to 1 terabyte of memory, and it integrates nicely with other memory allocators like Facebook's JE-malloc and Google's TC-malloc. It complements them nicely. We also implement many algorithms in addition to the standard stuff that you'd expect, like maps, reductions, scans, filters. We also have more advanced algorithms like semi-sorts and histograms, and we also provide very high performance tested implementations of advanced versions of several common primitives like sorting. So we have a cache oblivious sample sort due to Blelloch et al., and we also provide high performance integer sorting algorithms. So that's it for ParlayLib. There are many things we'd like to do to improve the library in the future. One thing we'd like to do is try to integrate more primitives into it. So several research projects have already built on the code that has become ParlayLib. Several graph-based projects like the graph-based benchmark suite and the Ligra graph processing framework use code from Parlay, and we think it would be nice if we could integrate some of the graph primitives from those tools into Parlay so that Parlay itself can provide useful primitives for dealing with graph code. And there's also the Parallel Augmented Maps project, which is essentially a high-performance balanced binary search tree for C++. And it would be nice if we could integrate something like that directly into Parlay so that Parlay could provide interfaces for ordered sets based on these parallel balanced binary search trees. And it's an open source project, so we strongly encourage others to contribute, and we invite people to add new algorithms, performance improvements, and bug fixes to the library. Thanks for listening. Let me know if you have any questions.